In this video, we're going to talk about linear equations in two variables. And so one of the defining properties of linear equations is their slope, all right? The slope of a line depicts or is a measure of the actual steepness of that line, all right? It's a measure of the steepness of the line. And so usually when people hear the word slope, they know that we usually use the lowercase m as the variable that we denote with slope. And it is basically your rise over your run, or you can use it in the calculation as your change in y over your change in x between any 2 points that a line passes through. So for instance, if I have a point here and a point here that my line obviously passes through, and we're in our xy plane, and I call this point here x1 sub y sub 1, and then this one here x2 comma y sub 2, then I can get a measure of our slope or our steepness of our line by doing the change in y over the change in x. Again, we're in our xy plane, and so if I want to know something about my change in y over our change in x, I'm actually going to move this over here. Actually, let's do this. Let's move this over here. That's this ordered pair x1, y1. And so if I want to know the rise over the run or the change in y over the change in x, all I have to do is draw the distance that I rise in order to get from one point to the next, and then to draw the horizontal line that represents the run, right? So this is my rise, this is my run. Again, your rise is your change in y, your run is your change in x. And basically you're doing a subtraction. Change in means do a difference. And so the difference in my x values here is x2 minus x1, and the difference in my y values here is your y2 minus y1. Now here I'm not using absolute values here because I'm not saying that it's a difference. I'm just doing a difference, all right? So I can do the difference in the opposite direction also, okay? And so this change in y over change in x is y2 minus y1, and my x2 minus x1 is my change in x. And so this is the formula for our slope, all right? And so if we think about different types of lines, right, these are 4 representations of the types of lines that we'll see. In part A, our line is increasing or rising from left to right. In this case, our slope is greater than 0 or positive. Here, our line is falling from left to right, and in that case, our slope is negative or m is less than 0. Here, our line is neither rising nor falling from left to right, it's remaining constant. In this case, we have a horizontal line. So this is a horizontal line. And here we have a vertical line. And again, our graph is not running anywhere, but it's going up and down, right? And so if I want to know our slopes, right, lines with positive slopes rise from left to right, we can say that the lines are increasing. That's from graph A. Lines with negative slopes fall from left to right. We can use the word that the lines are decreasing. That's in graph B. And then the greater the absolute value of the slope, the steeper the line is, whether it's increasing or decreasing. So that'll get the steepness has to do with the magnitude of that slope. And the slope of a vertical line here, remember, we're only rising, right? So we only have a y2 minus y1 equaling a value, but there's no running from left to right. And so our run would be 0. Well, anytime we divide by 0, we get a slope that is undefined, right? So the slope of a vertical line is always undefined. And the slope of horizontal line, okay, well, we do have a run. We run, x2 minus x1 is going to be some number, but we don't go up or down, right? We stand on the same line that's horizontal. So our rise is going to be 0. Well, 0 divided by some number is equal to 0 all the time. And so the slope of your horizontal lines are 0, all right? Let's find the slope of the line that's passing through these 2 points here. Again, until I memorize this formula here, I'm always going to write it out. We can label our points x1, y1, x sub 2, y sub 2. And we can plug in the values into that formula. -7 minus 3 over 4 minus negative 5, we get negative 10 over 9. All right, that's the slope of this line that passes through these 2 points. There are, again, we talked about the standard form of the equation of a line. We usually don't leave use this formula here to write equations of lines. We usually either use the point slope form of the equation of the line or the slope intercept form of the equation of the line. The point slope form is given here, where m equals our slope, of course, and x sub 1 comma y sub 1 equals a point that we know that our line passes through. So once I get these two pieces of information, I can substitute them into this equation, and then we'll have a formula for the equation of our line. A similar formula has to do when we know the slope and the intercept, and this is the y-intercept to be specific. Then m here equals your slope once again, and b equals your y-intercept. All right, and so we have our line y equals mx plus b. We've already discussed the horizontal line. Remember, y equals some number. That k is your y-intercept. And then x equals some number. That h is your x-intercept. All right, and so we can use these bits of information to come up with the equation of a line. Just so you know, usually we leave our equation of our lines in this form right here because it's really related to function notation. All right, but it's not a requirement necessarily. And so in this example, it says find the equation of a line that satisfies the given conditions. I have m equals -3, that's our slope, and we know that our line passes through the point -5, 10. Well, we're given a slope and a point, and so that's a great setup to use our point slope form of our equation of our line. And so what I'm going to do is I'm going to substitute the values that we're given into that equation. Plug in the 10 for y1, -3 for the m, -5 for the x sub 1, right? So I get y minus 10 equals -3. That's the x plus 5. I can distribute. So, okay, I want to stop here. This is an equation of a line, right? That is it. That is the equation of a line. But we like to solve for y, get y on one side by itself, because when we move forward and talk about functions, we like to have y by itself because that's the same thing as the function notation. All right. So I'm going to distribute that -3x so that I can solve for y. So I distribute it to the x, and I distribute it to the 5. So I distribute the -3, not the -3x. All right, plus 10 on both sides, or add 10 to both sides, and we'll get our equation, right? And one way that we can check ourselves is by plugging in this x value, right? So if I plug in -5, here I get a 15 minus 5, which will give us 10, which is the y value, right? And so there we go. So we know that we have the equation of a line. All right, this is generally where we like to go, unless they specify to write your equation in some other form. Let's look at another writing an equation of a line, right? We want to write the equation of a line that passes through the point -5, 3, and 4, -7. If you remember from our notes earlier, these are the same 2 points, and we've already found that the slope was -10 over 9, right? And so I know that my slope equals -10 over 9. I'm going to use the other equation, the slope intercept form of the equation of the line this time to write this equation, right? So notice we're not given an intercept, but I'm still going to use this equation here, okay? Just so that you see an example. And so when we do that, I'm just going to substitute a point that I know my line passes through. I'm going to let my x be replaced by -5 and my y be replaced by 3. And I know my slope is -10 over 9. And that gives me an equation with just b in it, right? So I get 3 equals 50 over 9. And so notice I have a denominator of 9. And so if I multiply 3 by 9 divided by 9, I'm going to get 27 over 9. And I'm just doing that so that I can go ahead and simplify, right? If I subtract 50 over 9 from both sides, I'm going to get a -23 over 9 equals b. And so my equation of my line is going to be y equals my slope, which is -10 over 9 times x. Instead of saying plus -29 over 3, I'm going to put minus 23 over 9, right? And notice if I plug in a -5 here, I'm going to get a positive 50 over 9, which I subtract 23 over 9. That gives me 27 over 9, which is 3, which is the y value there. And if I were to plug in this point right here, I see that I get the right solution as well. All right. And so that is that example. We want to talk about parallel lines. Parallel lines, two lines are parallels if they never intersect. And so if they never intersect, that means they have to maintain the same slope. So the slope of all parallel lines are equal, all right? Two lines parallel and their slopes are equal. Well, perpendicular lines, they intersect to form right angles. Right angles are 90-degree angles, right? And so I should notate that here that these two angles are this angle here is a right angle, making four right angles, right? And it just so happens that the slope of perpendicular lines are negative reciprocals, right? And so, for instance, if I know that one line has a slope of 3, then the negative reciprocal is the opposite sign, which is negative, and then the reciprocal of 3 is 1/3, all right? For instance, if I have something like negative 3/4, right? Then the slope of the line perpendicular to it is the negative reciprocal. So since this is negative, the opposite sign of that is a positive, and then the reciprocal of 3/4 is 4/3. One more. If I have 1, the negative reciprocal of that is -1/1, which is the same thing as -1, right? So the slopes of two lines that are perpendicular are negative, and some people like to use, and it's probably a better word, opposite reciprocals, all right? And so what we're going to do here is we're going to write an equation in standard form, all right? So this is telling me to write the equation in standard form using only integers for each of the lines described. And it says to draw a sketch of the lines. We're not going to do that part. We're just going to write the standard form of the equation of the line, right? We want a line that's parallel to the line 2x plus y equals 9, and it passes through the point -4, 3, right? So if I'm going to write the line that's parallel to that line, I first need to know the slope of this line, right? Well, if I solve this line for y, solve this equation for y, that's by subtracting 2x from both sides, we see the slope of this line is -2. And so since the line that I'm going to create has to be parallel to that, then its slope has to also be -2, right? So it has going to have a slope of -2, and we know it passes through the point -4, 3. So what we're going to do is we're going to use this information, and what I'm going to do is I'm going to put it into the point slope form of our equation of our line, and then we'll write our equation in standard form, all right? So y minus y1, my y1 is 3, my x1 is 4, right? Is -4. So when I subtract the -4, I'm going to have a +4 here. I'm going to go ahead and do that. I want to write the equation in standard form. Standard form, remember, is ax plus by equals c. So I'm going to distribute everything and then get my x and y on one side and my constant terms on the other. So I get a -2x minus 8. I'm going to add 2x to both sides and add 3 to both sides. And I get this as my standard form, right? 2x plus y equals -5. Let's create the equation of a line that's perpendicular to this line that passes through the point 5, 8. And again, we're going to write it in standard form. So again, I got to figure out what the slope of this line is, right? So remember, we solved this for y and get into slope-intercept form so that we can see the slope visually. So I subtract 3x from both sides, divide both sides by -1. I get y equals 3x minus 6. So the slope of this line is +3. So the slope of the line that I'm going to create is going to be the negative or the opposite reciprocal, which is going to be -1/3. And we know that the line is going to pass through the point 5, 8. And so this time, instead of using the point slope form, I'm going to go back to my slope intercept form, but then I'm going to write my answer again, ax plus by equals c. All right, and so let's do that. I'm going to plug in this for x and that for y, and I have my -1/3 in for m. I'm going to get a equals -1/3 times 5 plus b. That's 8 equals -5/3 plus b. Now this is thirds here, right? So I'm going to multiply by 3/3. That's 24/3 equals -5/3. And if I add 5/3 to both sides, that'll be 29/3 equals b. And so I'll have y equals -1/3 x plus 29/3. And if I want to write this in standard form, I need my x's to be on the other side. So I'm going to add 1/3 x to both sides. And I only want to use integer exponents because the instructions, okay, not exponents, but using only integers as our coefficients. And so instead of having this stuff divided by 3, I find the lowest common denominator of all of my fractions, which is 3. So I multiply both sides by 3, and I get x plus 3y equals 29. And that's our introduction to linear equations.